Thank you, ICTP and the organizers, for arranging this session on the Indian Ocean variability and tunnel connections. Here I will be talking about the warmest waters on the Earth's surface, the Indo-Pacific warm pool, and its impact on the global weather and rainfall patterns. This talk has three key elements. We will go through it one by one, but let me introduce the key points straight away. The Indo-Pacific warm pool here, defined by sea surface temperatures primarily about 28 degrees Celsius, is rapidly warming and expanding at the rate of 400,000 kilometers square per year. Now that's the size of California every year. You can imagine the size of expansion of the warm pool. Now, this warm pool has changed the residence time of MJO, the convective bands which uh, travel from the west to east over the tropical Indo-Pacific region. It has shortened the MJO lifespan in the Indian Ocean by about 3 to 4 days, while it has prolonged that over the West Pacific by about 5 to 6 days. And that obviously has an impact on rainfall patterns, regional rainfall patterns across the globe. It has increased rainfall over the Madden continent, North Australia, Southwest Africa, Amazon region, and other regions as well, while drying over the west and east coast of the US, Central Pacific, Ecuador, East Africa, and parts of North India and China as well. Now, this is a study carried out with my PhD student Pani Dasgupta and my collaborators at NOAA, University of Tokyo, and Washington. Most of you know about the MJO. Basically, they are easily identified as convective bands that initiates in the west or central Indian Ocean and moves on to the east as part of a coupled convective system. It moves to the East Indian Ocean over the Madden continent to the Pacific. Most of them dies over here along the over the Madden continent or in the Central Pacific. But some of them, the remnants, get carried even into the Atlantic. The activity of MJO at a particular region is denoted by its phases. So we have phases from 1 to 8 from the Indian Ocean to the Central Pacific. There's been quite a number of studies on how the MJO has changed over time in the last several decades. But an understanding based on observations, especially on the individual phases, is not there. So studies have mostly suggested changes in MJO amplitude, frequency, and propagation, although a clear understanding of its life cycle, how much it spends over time, and how it has changed in the last several decades based on observation. That's pending. And why does these phases matter? Why do individual phases matter? Here is an example. This is a composite of tropical storm activity in the Indo-Pacific. Red colors show enhanced activity. And as you can see, during MJO phases 2 and 3, tropical storm density is larger over the Indian Ocean, while it is lesser over the rest of the regions, right? And similarly, during MJO phase 6-7, tropical storm density is larger over the Maritime and the West Pacific region, while it is lesser over the Indian Ocean. And if you see some of the recent events, for example, the recent feast of storms in the Western Indian Ocean, this is now happening more frequently. This is a picture from December 2019. Feast of storms, like 4 or 5 storms occurred all together on the same day. And this kind of aggravated the locust outbreaks in Africa, which spread on to rest of the Indian Ocean region. This was triggered by a perfect recipe of ocean atmospheric conditions, a positive Indian Ocean dipole, and a rapidly warming Arabian Sea, which triggered strong convective systems over this region. And also the atmospheric conditions were such that the MJOs were in the phase 2 and 3, triggering multiple storms over this region. Now, MJO phases matter over other regions other than tropics also. When MJO is over the Indian Ocean, that is in phase 1, 2, or 3, the US is wet and cool, while the MJO is over the maritime continent over here, or the Central Pacific. The US is dry and warm. It's the same for the temperature during MJO phases also. And how does that happen? It happens through these atmospheric rivers. So whatever happens in the tropics, especially during MJO in the west, in the maritime continent, these are carried over by rivers in the atmosphere. This particular atmospheric river is also known as the Pineapple Express. Why pineapple? Because these rivers travel over Hawaii and carry the fragrance of pineapple from this region. Or is it so? You can Google and see. Anyways, this is a beautiful example of how the MJO is linked. MJO, a convective system in the tropics, is linked to weather conditions in the extratropics, like the US. Now, the playground of MJO, that is the Indo-Pacific warm pool, and this warm pool has been expanding, as I told you earlier. Studies show that this is directly linked to human-caused emissions of greenhouse gases. And these are observed changes in SST, and model studies show that by natural forcing only, the expansion won't happen. But the expansion has been, model studies show that the expansion, more than 93% of the expansion is due to greenhouse gas forcing only. And if you add the other forcing like aerosol and all, that compensate for this increased warming happening over the Indo-Pacific region. Now, this is a time series on the right that show more details. You can see the black line over here that shows the change in warm pool intensity, and similarly over here the warm pool area, this is for the warm pool area, it shows a consistent increase in warm pool intensity and area over time over the Indo-Pacific. Now if it was natural forcing only, the blue, you can see of course there is an interannual variability, but there is no consistent increase or rapid warming happening over this region. But when the forcing is greenhouse gases, you can see the Indo-Pacific, the intensity of warm pool is increasing consistently with respect to observations, similarly for the warm pool area as well. So these studies, past studies have shown that human-caused emissions, man-made emissions, have a large contribution or the most significant contribution to the Indo-Pacific warm pool expansion. Now let us have a closer look into how the warm pool has expanded over time. Now these are from observations for more than a century. I have shown different snapshots of the trends during different seasons because the location of the warm pool during summer and winter are different with respect to the solar insolation during the seasons. If you look at summer, the warm pool is located mostly along the equator and north of equator. And this is a picture of the warm pools. You can see the color scale over here. So most of these deep brown colors indicate the warm pool region. Okay, these are temperatures above the 28 degrees Celsius. These deep brown colors. You can see the warm pool is covering a large area of over the Indo-Pacific. Now, if you look at the recent period, these colors are deepened, right? So it means that the intensity of the temperatures, sea surface temperatures, have increased over region. And it's not just the intensity, the area covered by these deep brown colors have also expanded, both zonally as well as meridionally. Now that's happening over the winter spring region time also, when the MJO is active over the Indo-Pacific. You can see, especially over the maritime continent, that region, the warm pool intensity and area have increased consistently in the recent decades. This is a animation of the SST changes of warm pool during this region. Above this pink colors here, bright pink colors here shows temperatures above 29 degrees Celsius. And it has been expanding, and this will continue to expand. And this is a picture of the SST trends. So earlier we saw the mean SSTs, how the mean SSTs have changed. So if you look at the trend, the change in temperature, you can see that the largest change is over the Indo-Pacific region, particularly around the maritime continental region. And over this region, the Indo-Pacific warm pool has expanded quite rapidly. Our calculation shows that the Indo-Pacific warm pool has doubled in size. So the rate of expansion, if you look at the long-term period, it was about around 230,000 square kilometer. That's about the size of the state of Washington, which is a small to moderate size for a US state. But the rate of expansion in the recent decades, since 1980s, it's about 400,000 square kilometer per year. That's the size of the state of California every year. And the statistical analysis that we did with these changes in the Indo-Pacific warm pool shows that this expansion is quite statistically significant for a region like the warm pool. Now, how has the MJO lifespan changed over time with respect to this warm pool expansion? Has this changed the lifespan at all? So most of you know that MJO, the time scale of MJO is around 30 to 60 days. It's also called a 30 to 60 day oscillation. So sometimes the MJO events last for around 30 days, sometimes up to 60 or more days. If you look at how the MJO lifespan has changed, the total lifespan have changed between 1980s and 2020s. You can see there is interannual variability, but the total lifespan has remained more or less same, right? Which means that even though the Indo-Pacific has warmed or has changed, the total lifespan has remained quite same. Now, so that doesn't tell us how the MJO has changed over time, right? But the impact of it can be extracted only if you look at MJO phase-wise. So what we have done is we have explored the changes in MJO at different phases, like phase 1, phase 2, phase 3, up to phase 8, and calculated the residence time over each of these phases or these regions. So what we see is that for the Indian Ocean, the MJO phase duration is decreasing over time. So if the MJO phase duration during the beginning or during the early 1980s was around 19 days, 18, 90 or 20 days, now it is around 15 days. So that is a change of about we see a change of around 3 to 4 days. So that means that the MJO is spending lesser time over the Indian Ocean than earlier, 3 to 4 days lesser convection over the Indian Ocean. Meanwhile, the estimates of phase duration over phases 5, 6, and 7, that is over the maritime West Pacific region, shows that the phase duration or the residence time over this region has increased over this period. So a PDF analysis of MJO phase duration shows that the MJO phase duration in the early 1980s was around 17 days. Now it is around 23 days. So that's about 5 to 6 days difference. So if you put this together, we will see that the MJO is spending less time over the Indian Ocean now than earlier and more time over the maritime West Pacific region. Now, how is it related to the Indo-Pacific SST conditions? So here what we did is we picked up that changes in the maritime continent, the life cycle of MJO, and correlated it with the ocean atmospheric conditions. So we see that the that the changes in MJO have the largest correlation over the Indo-Pacific region, especially over the West Pacific region. So here the SST changes are well correlated with the MJO changes, and similarly the atmospheric circulation also. So there is when the MJO convection is enhanced over the maritime continent, it is also related to uh, upward wind, increased upward wind conditions, denoting more convergence over this region. And there is also an increased humidity denoted by this orange reddish colors. So basically, you have a warm pool region here with increased SST, which prolongs the MJO-related local convective activity. It also drives uh, it also drives more moisture from the Indian region, which is why the Indian Ocean region might be having a drier subsidence compensating for that over the Indian Ocean. So basically, we are come to that understanding that the MJO changes over the maritime West Pacific region is largely driven by SST warming over the West Pacific region. Now, the humidity trends here also show similar increase over the West Pacific. This is the West Pacific region where the MJO activities has increased. Over the Indian Ocean region, where there is a subsidence related to this increase, there is a related decrease in the specific humidity. That has a profound impact on global rainfall patterns. For example, obviously, with increased convection and increased MJO activity, we have increased rainfall over the maritime continent, north parts of North Australia, Southwest Africa, and also parts of Amazon. Meanwhile, we have drying because the convective activity is more located over here. We have drying over the Central Pacific, Ecuador region, and also parts of US which are connected to this uh, to the MJO through the river atmospheric river. So when MJO is more located over here rather than over the Central Pacific, that means there are less remnants passed over to the US through this atmospheric river flows. Now, so this is a composite difference in rainfall between those events when the MJO is longer or have a longer residence time over the maritime continent compared to that when the MJO has a shorter lifespan over the maritime continent. So the trends in rainfall, the generic trends in rainfall also have a similar picture with increase over the maritime continent, North Australia, these regions, and a decrease in parts of US and all. Now remember that these are changes or composites picked up for the winter spring time when the MJO is active. Now, if we look at the time series, we can even pick up some of the extreme weather events that happened due to these MJO changes. For example, in 2011, we had Indonesian floods over this region when the MJO lifespan or the residence time was much high. Similarly, we had East African droughts also during this region when MJO was stronger over the maritime continent. Similarly, we had 2013 to 2014 we had the California droughts when MJO was in phase 5, 6, and 7. This here MJO lasted for 25 to 28 days, while during the other event the MJO lasted for about 30 days over the maritime continent. So those are the global impacts of these kind of changes in MJO, and this study has been published in Nature as titled as Twofold Expansion of the Indo-Pacific Whirlpool Warps the MJO Life Cycle. So to summarize once again, the Indo-Pacific Whirlpool has been rapidly expanding and also the intensity also has been increasing. This has changed the residence time of MJO over the Indian Ocean and the West Pacific region and has altered the global rainfall patterns. Now that's quite a large impact for convective system in the Indo-Pacific, which moves from the Indian Ocean to the across the tropics and influence the global rainfall patterns. Thank you. Thanks a lot for listening this talk.